previous video. So in the previous video we had discussed about classification on the basis of this hydrolysis. So now we will be discussing on the basis of classification on the basis of reducing nature. Now on the basis of reducing nature, these carbohydrates can be classified into two categories. So obviously the one is reducing sugars. Now these reducing sugars are capable of reducing tolerance reagent or failing solution. Okay, so those sugars or carbohydrates which are capable of reducing tolerance reagent or failing solutions are known as what? Are known as reducing sugars or carbohydrates. And examples, and please remember, examples are very important. All monosaccharides and disaccharide except sucrose. Except sucrose is known as what? They are all reducing sugars. Now on the other hand, whenever we talk about non-reducing sugars, now obviously they will not be able to reduce tolerance reagent or failing solution, and example is sucrose. Please remember this part, okay? In the previous video, you had discussed about the open chain structure of glucose and fructose. So let me write the open chain structure of glucose: C double bond O, 1, 2, 3, 4, 5, 6. So you have CH2OH. Here you have H, OH this side, OH, OH, and OH. So this is carbon number 1, 2, 3, 4, 5, 6. Okay? And this side you have hydrogen, 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 and hydrogen. This is the open chain structure of glucose. Now, this open chain structure, okay, can go to the cyclic form also. It can go to the cyclic form also. That means glucose can stay in this form. This is the open chain structure. This is the open chain structure, and this can also go to the cyclic form. Okay, then let me write how it goes to the cyclic form. In case of glucose, all these carbons are numbered 1, 2, 3, 4, 5, and 6. Now, in case of glucose, this carbon number 5, this OH contains lone pair. The carbon number 5 in which OH group is attached. Now this will form a bond with carbon number 1. It will form a carbon bond with carbon number 1. Okay. Now based on this, now what will happen? This will shift this side. This H will be shifted to this O minus. That is, it becomes after this particular reaction within the molecule. OH group will be here, and oxygen, this oxygen will be bonded between carbon number 5 and carbon number 1. Okay, and here with O minus, this H will be shifted here. So now let me write its structure on the other side. So carbon number 1, 2, 3, 4, 5, 6, CH2OH. So our main focus is here between carbon number 1 and carbon number 5. So let me write this forms a bond between carbon number 1 and carbon number 5. 1, 2, 3, 4, 5, and 6. Now, as I told you, this O minus will attract this proton. As a result, it becomes what? OH here. Therefore, if you write OH group is this side, and this hydrogen is this side. Now the rest of the groups you can write it according to as it is here in this case also. So in carbon number 1, OH is this side. Now carbon number 2, OH, OH, and OH. And other remaining are the valency of carbon is filled or fulfilled by are fulfilled by hydrogens. It is fulfilled by what? Hydrogens. Don't forget this part, okay? Now, here, now this OH group, instead of this side, it could be on the other side also, okay? Now, the rest of the compound in this case will be same. So let me write, once I write it will be more clear. 2, 3, 4, 5, 6. CS2OH. And the bond is between, this oxygen is bonded between carbon number 1 and carbon number 5 as in this case. And now here rest of the thing will be same. OH, 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 and here you have hydrogen, hydrogen, hydrogen. Now here in this particular structure, cyclic structure, you have OH this side. Now instead of having OH this side, you could have it on the other side also. So OH here and H here. So these two are, this let me write, this is number 1, this is number 2, this is number 3. This number 2 and number 3 are in cyclic form. Okay? And these are the cyclic structures of glucose. One is alpha D glucose, the other one is beta D glucose. So whenever you have OH this side, okay, that is known as what? Alpha D glucose. It may look confusing, but once you understand it, by looking at the structure, you might think it is so confusing. No, but once you know the trend, how it is done, okay, then this becomes very, very simple. So whenever you have OH group on this side, on the right hand side, that is known as alpha D glucose. Now here, since OH group is on the left hand side, then this is known as beta D glucose. So here you have hydrogen. As you have hydrogen here also you have hydrogen. So now let me write these two structure in cyclic form. This is also cyclic form, but let me write in this 6-membered ring type of structure. Please follow this, okay? So while writing this structure of glucose, you have to make this 6-membered ring. Say this oxygen is bonded between carbon number 1 and carbon number 5. Don't forget. So this is your carbon number 1, 2, 3, 4 and 5. So what do you have? You have this 1, 2, 3, 4 and 5. Yes or no? And the 6th carbon is here. CS2OH. Okay? This is carbon number 1, 2, 3, 4, 5 and this is carbon number 6. This is carbon number 6. Okay? Now, while writing these groups, you have to remember one thing. If you are writing, say this on the right hand side, whatever OH groups are present, you write it below this ring. Okay? So I am starting with carbon number 1. Carbon number 1, OH group is attached on the right hand side. So you have OH group in the below side. So I am writing for the right hand side OH group below this ring. And which are on the left hand side, I am going to write up here. Okay? So hope this is clear. Carbon number 1. On the carbon number 2 also you have OH group on the below side. On carbon number 3, it is on the left hand side. So I am going to write it at the top over here at carbon number 3, OH. Carbon number 4, it is on the right hand side. Therefore, I am going to write it below over here. So these are carbon number 1, carbon number 2 OH, 3, 4, 5 is bonded with the oxygen, this oxygen and carbon number 1, and the remaining are filled with hydrogens. Hope this is clear now. See, once again let me repeat. whichever OH groups are on the right hand side, you are writing it below this structure at the downside, and on the left hand side, whatever groups are there, you are going to write above this ring. Okay, so this here, now here you got the ring form of glucose. Now in this ring form, you have to focus on carbon number 1. This is carbon number 1. This on carbon number 1, you have OH group on the below side. Therefore, it is known as what? Whenever this OH group is present below this ring on carbon number 1, then it is known as what? It is known as alpha D glucose. Similarly, the structure of beta D glucose can also be drawn over here. So let me write the structure first. So the structure will be exactly same at carbon number 2, 3, 4, 5, 6, everything same, only differs in carbon number 1. So let me write whatever groups are present at carbon number 6. This is carbon number 6, CH2OH. So up, there is other way of writing it also. This is carbon number 6. If OH group is on the upper side, on carbon number 5, it will be below. Then it goes up again. Then it comes below. So this is also another way of remembering how these OH groups and S groups are written on this ring form of this glucose. And this structure is also known as what? Pyramus structure of glucose. Okay? Now, here, whenever you had at carbon number 1, whenever, please focus here, whenever at carbon number 1, you had OH group at the below side of the ring, that was alpha D glucose. Now here, since the groups are on the other side, see here you have it on the right hand side, and here in beta D you have it on the left hand side. Therefore, here OH group will be present at the above side of the ring, that is above the ring, and H will be present here. Now this is known as beta D glucose. This is CH2OH. Now this is known as what? Beta. So whenever you write beta, how do you write? You draw it upward first, like this. So this is a way to remember it. While writing beta, you're writing upward. You're writing beta upward. No? Therefore, you have to remember at carbon number 1, OH group is above the ring. This is also another way of remembering it. So there are so many ways you can use to remember the structure of alpha D glucose and beta D glucose. So let me repeat it once again. So carbon number 2, 3, 4, 5, 6, the configurations is exactly same in alpha D glucose as well as in beta D glucose. What differs is in the arrangement of hydrogen and OH at carbon number 1. So whenever you have OH group above the ring, here, this ring, above the ring, then above the ring, while writing beta, you have to draw it upward. You have to draw it upward, means OH, whenever OH group is above the ring, that means it is a beta D glucose. And the other way, that is when OH group is below the ring, that will be known as what? Alpha D glucose. Hope this is clear. And you have to remember that whenever glucose is present, okay, there is this is an equilibrium sign. Can you see that? Some amount of glucose stays in open chain structure, some of them stays in what? This is alpha D glucose, and some of them they stay in beta D glucose form. Now, similar to this, we have the structure for fructose also. Hope this is clear. Fructose also stays in cyclic as well as open chain form. So for fructose, so in our previous video, I have given you the open chain structure of fructose. I hope you still remember it. You have CH2OH at carbon number 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, CH2OH. And at carbon number 2, you have ketonic group. Please don't forget. And the rest of the arrangement of hydrogen and OH was similar to that of glucose. H, H, H. Okay, so this in this structure, this is open chain structure of fructose. This is fructose. Okay, so this is open chain structure. Now, in case of fructose, what happens is this is carbon number 1, 2, 3, 4, 5, 6. In carbon number in fructose, what will happen? This lone pair of oxygen of OH group on the 6th carbon. Please don't forget, on the 6th carbon now will form a bond with this carbon at carbon number what? Carbon number 2. This is carbon number 2. Okay? Therefore, let me write the structure in this side. As in case of glucose, you have two different structures, alpha T and beta T. Now, what will happen? You have, so while writing this, we have to start with carbon number 2, that is C. You can have OH this side. Yes, you can have OH this side, and this carbon is attached to carbon number 1. Carbon number 2 is attached to carbon number 1, which contains CH2OH group. If it is not clear, let me write 1 second. So in fructose, since the bond formation takes place between carbon number 2, therefore we are starting with carbon number 2. Here this is attached to this becomes OH now. As in case of glucose, this H will be shifted to this oxygen, so it becomes OH. Now this carbon is attached to what? CH2OH. So this is CH2OH. 3, 4, 5, 6. So here the bond formation between carbon number 6 and 2 takes place. Therefore, we have a oxygen which is being attached with carbon number 2 and carbon number 6. This is 3, 4, 5 and 6. Yes. So here you have CH2 group. Here CH2 group, you have an oxygen in between. Now other can be written as it is: hydrogen, OH, OH, OH. This side you have hydrogen and hydrogen. Now since this OH group, please look at this part. This OH group again is on the right hand side. Therefore, it is known as what? Alpha D fructose. Now it is fructose. Similarly, here carbon number 2, you have OH this side and CH2 OH this side. 1, 2, 3, 4, 5, 6. You have CH2. Now these two are attached with oxygen. Carbon number 2 is 1, 2, 3, 4, 5 and 6. Now here OH is attached this side, then it goes this side, then OH, carbon number 2. So at carbon number 3, say at carbon number 3 what you have? At carbon number 3 you have OH on the left hand side. So here we have OH, then OH this side, then OH here. So this is hydrogen, this is hydrogen, this is hydrogen. Now since here this OH group at carbon number 2 is on the left hand side, therefore it is known as what? Beta D fructose. Now this also gives us what? 1, 2, 3, 4, 5, 6 membered ring. Here also we have 6 membered ring. Here also we have 6 membered ring. So now since I have taught you the structure of glucose, the Pyramus structure of glucose, I urge you to write the structure of this particular form in this ring type structure and also for this, and that would be your this assignment, okay, for today's video. Hope you understood this. Keep practicing. Thank you.